Okay, so due to the challenge of network, I'm making a record for you. We resume the lesson for today, originating from yesterday's discussion, where we talked about the three states of matter. In the three states of matter, we discovered that we have solids, liquids, and gases. Then today we talk about characteristics or properties of the three states of matter. When we talk about characteristics of the three states of matter, what are we talking about? We are talking about ways on how we can distinguish a solid, a liquid, or a gas from among themselves. So we are going to talk about the shape, the volume, compressibility, and the arrangement of particles and their movement. How do they differ from each other? Henceforth, we start from the shape. How can we use the shape to differentiate solids from liquids or liquids from gases? Someone yesterday gave us an example of solid being a stone, wooden block, freezes, so on and so forth. Imagine you have a wooden block and you also have a stone. These two are different, but they are a very good example of a solid. And how is their shape? Their shape is very fixed. You cannot play around with the shape of a wooden block. Hence we say they have a fixed shape. Let's come to liquids. Liquids have no fixed shape. They always get the shape of the vessel. If you put water in a cup, it will have the shape of the cup. The same water which was in the cup, you put it in a bottle, it will have the shape of the bottle. The same water, you put it in a glass jar, it will have the shape of the glass jar. Hence we can conclude to say liquids do not have a fixed shape. What about gases? Gases also do not have a fixed shape. Gases have no fixed shape. They are all over. They are all over. Whichever side you face, you still be able to breathe your oxygen and you still be able to breathe your carbon dioxide even without seeing it. It's invisible. Okay? We come to volume. Volume is quite common, especially in physics. When you'll be doing your school-based assessments, they are what we call SBAs, which makes about 20% of your local exam. Your teacher will ask you to calculate for density using different substances. So for example, maybe they have given you a wooden block, or maybe they have given you a stone. In a scenario where you are given a wooden block, then they request you to calculate for the volume. How do you calculate it? You say L times B times H. You measure the length, you measure the width, you measure the height, and then you multiply. So for example, you can say 2 times 3 times 2. Then that becomes your volume. If you are using an object which we call an irregular object, this just reminds me on objects. For the sake of learning, there are two types of objects that you are going to find. They are what we call regular objects, and they are what we call irregular objects. How different are they? Regular objects, these are objects that have regular objects. These are objects that have a shape. Irregular objects, these are objects that do not have a shape that do not have a defined shape. I think I can use the word a defined shape. Those are irregular objects. A very good example is a stone. Even if we give you a ruler and then we tell you to say, can you measure the volume of the stone? You cannot manage. So what can you do? You get a measuring cylinder, you put water there, maybe the water that you can put, it will go up to 10 mils. You lower your stone there. From 10, you discover that your water will rise from 10, probably maybe to 15 centimeter cubic. What does it tell you? It tells you to say there is an increase of the volume from 10 to 15. Meaning, for you to calculate your volume of the stone, you need to subtract 10 centimeter from the 15 centimeter, and then you can conclude that this stone has a volume of 5 centimeter cubic. So all solids, they have a fixed volume. Let's come to the liquids. Liquids also have a fixed volume. The water that you can put in the 10-liter container, when you put this same water even in a 20-liter container, it will still be a 10-liter of water. So they have a fixed volume. What about gases? Gases do not have a fixed volume. You can't control the gases. They move randomly. They move in whichever direction they feel. Some days you talk about diffusion and you see how these gases normally move. Let's come to compressibility. By the way, what do we mean when we say compressibility? The ability the ability to compress something. The ability to compress something. Are you able to compress a solid? Can you compress a table? Can you compress a stone? Can you compress an ice block? You can't. Solids cannot be compressed. Liquids cannot be compressed. When a 20 liter is full, you cannot compress a 20 liter which is full. What about gases? Gases can be compressed. A very good example of a gas which you can compress is a ball. The ball that we use for ball games. A bike tire, you can compress those. A balloon, you can compress those. Arrangement of particles. How are particles arranged in solids? Particles in solids, as you can see, they are closely packed. They are closely packed. This reminds me, there was a question, I've just forgotten the past paper, but I'll be able to recall it and I'll give it to you, which was saying, what name is given to the force that holds the particles tight in solids? The answer was cohesive forces. So these particles in solids, they are held together by the strong forces that we call cohesive forces. It is these forces that makes a solid to turn into a liquid when they are broken. So the process of breaking these forces, it makes this particle to change from a solid to a liquid. Then we come to liquids. Particles are slightly further apart than in solids. They are held together by weak electrostatic forces of attraction. As you keep on hitting a solid, you are making these particles to be weak. As they become weak, then they will be broken down into tiny particles and then it becomes a liquid. From there, we come to what we call gases. Particles are much further apart from each other. The forces which hold the particles together are negligible. Hence, there is no control. They move in whichever direction that they see to be worthy. That is the reason why we say particles here move randomly. The last part, it is the movement of particles. if these particles in solids are held together so strongly, let's assume, how do they move? They can't move. They can only vibrate. They can only vibrate. What about in liquids? Particles move by vibrating rapidly. They increase the vibration a bit, okay, because they are slightly apart from each other. In gases, particles move at randomly. Particles move at randomly. This is what is there on the characteristics of gases, liquids, and the solids. Now, let's go to the other side of the examiner. How do questions normally come just on this part? Just on this part. An examiner might ask you a direct question to say, can you explain how particles move in solids, in liquids, in gases? Or can you explain the arrangement of particles in solids, in liquids, and in gases? Sometimes it may be under multiple choice. It may be under multiple choice. They will draw different substances and then they will expect you to know them. Either this is a solid, this is a liquid, or this is a gas. Unless there is a question, if there are no questions, then let's go to the other side of the past papers and look for questions that were drawn from this part of the lesson that we had today. Otherwise, thank you so much.